Good morning, dear students. Continuing with our previous technique, implication method, I'll just show you for one more example how you can reduce the redundant states or eliminate the redundant states. I'm showing you with implication method. So, as I told you in the implication method, we start the optimization in the initial stage itself by eliminating the first row and the last column. So now the first row is eliminated. So I start with B, C, D, E, F and a G. Correct? Now I have to eliminate the last column. So I start with A, B, C, D, E, F. So I have eliminated the last column, that is G, and the first row, that is A. Okay. And you all remember our first step or first rule is to check for the output. If the output does not match, you have to mark with a double cross. So from A to B, if you check, output is not matching. A to F also output is not matching. From B, if I check, B to C, D, E and G. B to C, D, B to C, B to D, B to E and B to G. It is not matching. So mark with a double cross. Similarly for state C you do. So state C output is 0, 0. So D also it is 0, 0. For E also it is 0, 0. But for F it is 0, 1. So C to F output does not match. Next, go to state D. From state D, for state E it matches. For state F, if you see, D to F output is not matching. Okay, then D to G matches. Then if I go to E, E to F does not match. So E to F, that location or that cell does not match. Next, F to G also does not match. Okay, our first step is done. Our second step, what is our second step? What we are supposed to check for? Now we have done the first step where we have marked with all the cells where the outputs are not matching. Now we will mark the transitions. Okay. So I will mark the transitions. So A to B ruled out. A to C, if I check, it is on input 0, it is going to AF. Okay. And on input 1, it is going to BE. Write down that. Then from A to D, it is going to A to D and B to F. Next one, A to E, if you check, it is going to AB. You have to mark like this. On 0, first you write down, then you write down on 1. So it is B to G. Next, A to G is also valid. So it is AA and B to F. Right? B to F. So I have marked for state A. Similarly, for state B, which is valid, only B to F is valid. B to F means it is DG and CC. DG and CC. Next, here if I go to state C, C to D. C to D is, it is FD actually, but I will write it as D to F because always forward direction. D to F and E to F. Next, C to E. C to E is B to F, B to F and C to E is B to F and EG. Next, C to G. C to G, if you check, it is A to F, comma EF. Next, from D to E, it is B to D and it is GF. I'm sorry, FG. Next, D to G. If you just check D to G, it is AD and FF. Next, from E, if you check the transition, E to F is ruled out. E to G, it will be AB, comma, FG. So, we are done with all the transitions. Now, you have to go on checking whether the transitions are valid or not. Okay. So, now, if I check this A to F, so I have to go to that location of A to F and check. So, A to F, in this location you have a cross, means this is also not valid. So, you need not check for the second one if the first one itself is not valid. Next, go to AD. A to D is this cell itself, so it is valid. Now, you have to check for B to F also. If it is not valid, then you cannot. So, but B to F is also valid. You have some data here. Next, AB. A to B is not valid, so this will go away. Next one is AA. AA is self loop. B to F you have to check. B to F, yes, it is valid. So, I will retain that. Next, if I go to B, it is DG. D to G, if I check, I have some valid state. And C to C will always be valid because it's a self loop. Then D to F you go. D to F, it is not valid. So, this becomes invalid. Next one is B to F. If I check B to F, it is valid. But I have to check for E to G also. E to G is also valid. Next one is A to F. A to F, it is not valid. So, this becomes invalid. Next, if I go here, it is B to D. B to D is not valid. So, I will not even check for the second one. Next, A to D. A to D is valid. FF will always be valid. So, this is a valid state. Next, come here, you have AB. AB is not at all valid. So, this will go away. So, this was our first step. But you have to go the second round also because you would have cancelled something. So, here you would have kept it as a valid state, but it would have been invalid after the first phase. So, I have to check once again for the second phase. Now, I will check for A to D. A to D is the same location, it is valid. Now, I will check for B to F. B to F is also valid. So, this is a valid state. Next, I will check for AA. AA is self loop and B to F. B to F is valid. So, this is also a valid state. Now, I will come here. B to F. D to G you check. D to G, it is valid. CC is always valid. So, this also is a valid state. Next, come here. B to F. B to F is valid. E to G you check. E to G if you check, see in the first round, this was valid. Now, if you check, E to G is cancelled. So, this also becomes invalid. Next, come here. A to D. A to D if you check, it is a valid state. So, this is valid. So, this is cancelled. So, this is our final table. Now, we have to write the partition table to find our reduced states minimal table. Partition table. So, how do we start? You all know, I will start from the last state F. So, F, no valid transition. So, I will just mark it as F. Here, no significance of your small and capital letters, not a problem. Then, I will go to state E. In state E, do I have any valid? No, nothing is valid. So, I will keep F from the previous state and E from this. Okay, that is, I have to consider these states. These states, we could not eliminate or reduce. Next, come to state D. If I come to state D, do I have anything valid? Yes, this is valid. So, which is that location? D to G. So, I will write down D to G. What is this implied? D and G are equivalent states. So, I can retain one. Okay. D or G, but usually I retain D. Okay. Next, C. When I come to C, do I have any valid states? Nothing is valid. So, I will just write C, D, G, F and E. Next, I will come to state B. If I come to state B, I have B to F as valid. B to F is valid. then I'll write down C, then I'll write down DG, C. F is already here, B and F are valid states, so I'll eliminate this F here because this F will be repeated. So B to F, B and F are equivalent states. Next I'll come to state A. When I come to state A, you just see A to D is equal, A to G is also equal. So equivalent states are A, D and G. All these three are equivalent. Next is B to F, B and F. So B, one state we can retain. One more is C and DG. If you see, DG is already here. So this also we will be eliminating. So it is E. So this ended up in 4 states. So I just call this state as state A. I call this as B because A equal to D equal to G. That is the meaning. This is B equal to F. So I have retained B. Here I have retained A. And this is C. This is E. Now you all can draw the reduced state diagram A, B, C, E, and you know how to write the transitions. A on 0 where it goes, A on 1. This you can complete. Hope this is clear to you all. Thank you all.